Hi, everyone.
Hi, Prof. Evening. That scared me.
Okay, sorry. Hi, everyone. Can you guys hear me?
Yes.
Just give me a second. I'm trying to disconnect audio from my iPad. Give me a moment. Okay, now shouldn't get any feedback from my iPad. Okay, I'm going to connect up my iPad. Hang on. This will just allow me to write. Hang on here. What's going on here? No, not what I want. All right, cool. I'm all set up. Okay, let us get on with this. So this is a consultation session. Happy to answer your questions. I think a few of you had sent me some emails. I think I've replied to all of them. I think Benita, you had a couple of questions. Did you get your questions answered?
Yeah.
Yeah, you were asking about the distance vector protocol, right?
Yeah.
Yeah, so maybe just for the benefit of everybody, the question that Benita asked was whether the updates for distance vector need to be synchronous or can they be asynchronous? And the answer was, yeah. The nice thing about the distance vector algorithm is that it's distributed and the updates can be synchronous, meaning that, for example, maybe every 30 seconds or every 1 minute, everybody exchanges distance vector routing tables with their neighbor, or it can be asynchronous, meaning they do it only when there's a change, which is a little bit more efficient, right? Because if you had a large network and you were exchanging data every 30 seconds, that could generate a lot of unnecessary network traffic. So the nice thing is that in distance vector, the updates can be synchronous or asynchronous. And there's some nice convergence properties in either case, meaning that the nodes, like, modulo all the routing loops, modulo that they will discover the shortest paths from sources to destinations. Another question that was asked was, how do we count the number of iterations, right? In class, when we did our example for the triangle network, I told you it takes 44 iterations to converge and so on. And there was a question about how to count those. It doesn't matter so much, right? I mean, maybe to get an exact number, it will matter, but conceptually, I just want you to be able to differentiate between taking a long time to stabilize versus not taking a long time. If you need to make a decision, hang on, just guys, just give me a sec. Yeah, sorry guys. I was saying that you can, in terms of counting, let's say iterations or exchanges, just count the number of exchanges. So if A has to send the update to B and then B sends an update to A, you can count that as 2. Okay. So I think that was some questions that people had asked me. So I wanted to just let the rest of the class benefit. So are there any questions that would be help that people have right now?
Hey, Prof. I have something to ask you. So,
Yeah.
First of all, I still can't see my Quiz2 score in Gradebook. So, are you going to go through the Quiz2 today?
Yeah. I am going to go over some of the questions in Quiz2. I actually, let me check on Canvas. I had asked the TAs to publish it. Let me see if they published it. You're saying they did not publish it yet?
I can't see my score. I'm not sure about the rest.
Actually, I can see my score right now, but it's like over 40. So I don't know how to interpret this grade actually.
So you can see it, right?
Yeah, I can see the grade.
Who's speaking? Yurei?
Yurei is speaking. Yeah.
Yeah. And okay. So what is it you don't know how to interpret?
Because the grade is over 40, right? So I'm not so sure if it's the total grade for the Quiz2, is it 40 or is it, like, I don't know why it's 40. Yeah.
Why is that 40? I think it's, let me see.
Because I thought the quiz only have 15 questions. If
Yeah,
I can't remember.
Yeah, there were 15 questions. No, so there were 14 questions, right?
Yeah, but the grade is over 40, so I don't know.
Yeah, no, I don't know. It should be out of 42, right?
I'm not so sure actually.
Yeah. No, I mean, I think if you remember, the quiz was 14 questions, each worth 3 marks. So it's out of 42. I'm not sure. Yeah, this was entered by the TA, but don't worry, we'll fix that. I mean, the mark is correct. It's the marks that you got. Does that make sense? You right? But
I see. Yeah. No,
but it should be out of 42.
Hi, Prof.
Yeah.
Hi, Prof. Can you hear me? This is Chris.
Yeah. Hi, Chris. Yeah.
Yeah, I just want to check because you said that each mark is worth 3 marks, right?
Yeah.
But my result is my result is not in multiples of 3.
Yeah, because you can get credit for your explanation.
Oh, so it's
That's
okay.
what I asked for.
So
Yeah.
it's not one of it. Oh, okay.
It's not right or wrong, right? That's the whole reason for me doing this. Right. If you're right, if we just did true false or something, then yeah, it'd be multiple of or whatever. But I instructed them to be generous with partial credit.
Can I also check, is it possible to retrieve a soft copy of the Quiz2 script, because so I can see?
I don't have the soft copies, but anyway, I'll be going over the quiz questions. I mean, I can, yeah, I mean, I'll be doing that, so you should be able to at least see. I think right now it's maybe not feasible. Maybe if you want to, you can come see me later, and you can have a look. But right now I don't have them. Yeah, they're, like I said, they're not with me, and in any case, I don't have soft copies.
Okay.
Yeah.
Okay. Thank you.
Prof, for the past year paper you released, are we gonna get answers?
No.
Okay.
No, but you can feel free to ask me questions. I'm not gonna entertain a question that says, how do I do this problem? But I will help you get unstuck. If you remember, my philosophy has been, yeah, I mean, you work on it and I'll help you get unstuck. So you can.
Is it okay if I just want to know whether my answer is correct?
Yeah, okay. I mean, I suppose, yeah. But
Right.
as I said, I mean, if you're able to work through the problem without any doubt, likely you will, yeah, at least the approach is correct. I think to tell you whether it's right or wrong,
All right. That's
would
great.
I mean would involve grading it, right? Because like when we grade, we also give partial credit, right? So it's and that depends on the rubrics and all that good stuff. So if you want like if I don't know if there's a number and you want it to be right or wrong, I can probably check. But it's probably more important that you understand how to do the problem.
Yeah. That's
yeah.
the point. There's some questions I'm not really sure. I try. I'm just not very confident.
But feel free to ask. Like I said, I'm happy to help you get started or get unstuck or even review a concept. Yeah,
All right. Great.
that's not a problem. Yeah.
If
Okay.
you don't mind yeah, sorry, go ahead.
No, please go ahead. Who is this? CN?
Yeah.
Yeah.
If you don't mind, can you go? There's one other question for quiz 2 about how many distance vector, like how many iterations we take. Can
Yeah,
you go
yeah.
through that one first? Yeah, that's all for
Yeah,
me. Thanks.
If you don't
I
mind,
think someone's
I-
trying to speak also. Sorry.
someone's trying to speak. Who's trying to speak? Anyone want to say anything? Anyway, so that question, CN will cover. I am gonna just go through all the questions if it's all right with you, okay? But let me see if I can find that specific question. This was the question about a number of iterations. Sorry, can you guys hear me?
Yes.
Okay, so this was the question about number of iterations, right?
Yes.
Okay, give me a second. Let me find that one. Okay, let me share from my iPad. Give me a sec. Let's figure this out. Share screen. Okay, so I'm sharing screen. Hang on. Okay, this is it, right? Is it this question? The DV?
Yes. Thank you.
Okay. All right. What's? Hang on. Give me a sec. What is going on here? Zoom. Okay, so all right, okay, so we got the question here. Okay, what are your thoughts on this, CN? You were asking about this.
Yeah, I'm sorry. I didn't learn this part well. Not sure how to approach it.
Okay, anyone want to help, CN? How would you think about this problem? Benita, do you know how to think about this problem?
I first start with the stabilized DV.
Okay,
then
yeah. So we look at what happens when things have stabilized, right? So so that's a good approach. So when things have stabilized, you can know nodes know certain things, right? So we can say. Hey, by the way, when I write on my iPad here, can you guys see it?
Yes.
Okay, so before the change, what do nodes know, Benita?
the entire distance vector.
Yeah, so they know their like shortest cost paths to nodes, right? So before the change, now you don't even need to run the distance vector protocol. You just need to be able to inspect it, right? Because as I mentioned, the whole point of distance vector is to find shortest paths, right? So before the change, okay, B, so this is node B, knows what? So B knows that C, so CN, can you help me? Has, so C, like, if you look at C's cost to A, what does B know about that?
Shortest path cost is 2 through itself.
Right, so that's a problem, right? It doesn't know that through itself. So B knows that C has a cost 2 route to A, right? So this is one thing that B knows. And of course, B knows that it has a cost 1 route to A, right? So CN, am I saying your name right? CN?
Yes.
Yeah,
Yes,
so
you are the only professor who can say my name right, actually. So yes.
so okay, so this is before the change, okay? So now let's look at what happens after. Now I chose this in particular because I'm interested in what messages B and C exchange, right? Obviously B knows a lot of other things and the other nodes know other things before the change. But I focus on these two specifically because there's going to be a change in link AB, and I'm going to look at what happens with B and C. Okay, so what's going to happen after the change? Well, so after the change, so B is going to notice that its cost to A changed to 100, right? So what happens is this goes to 100, right?
Yep.
So what B is going to do is it's going to use the information it has, and it's going to try to reroute. Now, so after the change, now B knows that its friend C has a cost 2 route to A, and it has a cost 1 route to A, but its cost 1 route to A changed to 100, but it still thinks B has a it still thinks that C has a cost 2 route to A. So after the change, so can you guess what's going to happen?
Shortest route to,
Yeah.
to A is now through C with the cost path of 3.
Yeah, that's right. So B will try to use C, right? So B will try to use C, and well, as before, C will try to use B, right? Both, I mean, to get to A, right? We're trying to get to A. And the point is, these two will ping pong back and forth until what happens? When will they stop going back and forth?
When the true path cost has been reached.
So this will continue. Okay. Well, how about be a bit more specific, Xian? So until, well, remember, C has another route to A, right? What's its other route to
C
A?
reaches 6, I think. Yeah.
Right. So yeah, so its cost to A through D is 6. Right? So this ping-ponging back and forth will continue until C's cost to A via B is larger
Oh, okay.
than its direct cost, then its cost to A via D. Does that make sense? But I think this is where you're going, right?
Yeah.
Okay, and this is so now. Do you see what it should be, Xian?
C's cost to A will be larger.
Right. So if you look at it in the very first exchange, as you said, B will tell C, I'm gonna now use you to route to A. So my cost to A has gone to 3.
Yeah, I get it. Yeah. So it's,
and then C will tell, oh, my cost to A now has gone to 4. and then 5,
and
then 6.
and that's where the algorithm stabilizes, right? So answer
Yeah.
is C then.
Yeah, so what should this be?
Sorry, less than 10 C.
Yeah, exactly.
Glad to know I got this wrong. Thanks.
Hey, but at least do you get the logic now?
Yeah, thank you.
Okay, yeah, any questions on this? Anyone else? Actually, you know, to me, this is why I phrase this question like this, right? Because the actual number depends on how you define exchanges, right? So yeah, so don't worry about concept, not 44 or 45. Okay, let's do this. Let's go back. We can maybe take some of these. So this is question 1. How are we going to do question 1? Question 1 is pretty straightforward, right? So this says that the bold edges in this network form a spanning tree. So what can you say about the value of X? So if I know this is the shortest, is the minimum spanning tree, what do you know? Right, so what does minimum spanning tree mean? Let me see how this looks. If I make this bigger, can you guys still see it? Yeah, okay. Okay, good. So what does it mean, guys, for this to be the minimum spanning tree? So what is MST here? Amongst all spanning trees, the MST is the one with the smallest cost, right? So everybody with me, can we kind of have a little discussion here, if you guys don't mind? I think this would be a more pleasant experience for everyone involved.
Yep, sure.
Thanks, Yuan. What about the rest of you? Please type in. I know I recognize many of the people here. So please pipe in. So first of all, so maybe somebody can tell me how are we gonna approach this problem? Tiaye, how are you gonna approach this problem?
I think that if there are totally 4 ways and we need to choose 3 of them.
Exactly, yeah. Yeah, so we know that the minimum spanning tree must contain 3 edges, right?
Yes.
Yeah, that's a great observation. So then what's your thought process after that?
So we want to choose the minimal value.
Yeah, exactly. Correct. Choose the edges with the smallest cost, right?
Yes.
So obviously 3 and 5 should be in there, right?
Yes. And if
So-
X is
Right.
greater than 9, we will
Right.
not choose.
Right. So we know that what edge AB and BC are in the minimum spanning tree. And since I'm telling you X, so that means the third edge has to be AD or DC. And since X is in the minimum spanning tree, what do you know?
X is smaller or equal than 9.
Yeah, exactly. Because if X was not smaller than equal to 9, then meaning if X was greater than 9, then edge DC would be in the spanning tree. Okay? So everybody okay with this one? This is pretty straightforward. Okay, let's look at another problem here. In a multi-hop TCP/IP network. So it'd be great if people could just pipe in. We could make this go a lot faster, and it actually might be a bit more pleasant for you and me. So in a multi-hop TCP/IP network, the transport layer header could remain the same. You notice I said things like could, right? Could remain the same as the packet travels from source to destination. Is that true or false? It's not this, okay? You have enough information. So what do you think? Is it true or false? Does the transport layer information change from hop to hop? What do you think? Let me ask Pranati, what do you think? Is it something you have an opinion on? If you don't, you can say no. Okay. So what do you guys think? Can somebody give me an answer, please? I'm seeing a bunch of trues. Yeah, I think that it's possible. Yes. Okay, true. This can happen. So anyone wanna challenge me on this, or not challenge me, but give me a situation where this cannot happen. For example, again, I apologize if I get people's name wrong, if I call you by the wrong name, but Krishna Ramasamy.
Oh,
Why? Yeah, Krishna, can you give me an example where this might not happen?
Actually, I'm thinking about that.
Okay.
I thought usually network transport layer encapsulates data from network layer.
Yeah, that's exactly
Sorry, it's the
right.
other way around. Yeah.
No. So
But how this could happen?
no, I mean, so the network layer encapsulates information from the transport layer, right? So
Yeah.
you're right about that, but how? So you're right. Most of the time, transport layer remains the same from source to destination, hop by hop. But is there a situation where it can change? Yeah, Bonita has given you a hint in the chat.
Oh, so when there is a NAT, like NAT is administered in the network in IPv4.
Yeah, that's right. So this is without NAT, right? Because remember in NAT, we hijack the port number to differentiate processes on different computers. So with NAT, the transport layer can change, right? It would change through the NAT router. So yeah, this can happen, but only without NAT. Yeah, Bonita and Krishna, you're both right. Okay. How about Mac? So this was transport layer. How about this is now link layer? So I don't want to circle the answer.
Okay, this is, I will just answer this.
Yeah.
It's false because the MAC address changes from hop to hop, so it's false.
Yeah, absolutely. It's false. And it's precisely because both the source and the destination MAC change from hop to hop. Yes, exactly. And then I think, let me see, there was another question. Let me see if I can find which question it was. And we'll just put that to rest as well. It's question 8. Question 8 is about the network layer. So as the packet hops from source to destination, does the network layer header could remain the same or not? Is this true or false? Yeah, I'll give you there's enough information. So is this true or false? Oh, sorry, there's a question here. Benita says, Muhammad Asif Humayun, you said, what about the case of a single hop? Muhammad Asif, which question was that with reference to? Sorry, the previous one, meaning, just tell me, is it transport, link, or network? For the link layer, you want to argue, but I wrote in a multi-hop. Yeah. Does that make sense? So for single hop, you're right. There's nothing to change. So Muhammad Asif Humayun, are you okay with that explanation? Yeah. And then I think one more question. Wu Wanjun, what was your question about? On the same, you said what about on the same LAN? Also about link layer? Yeah, but I think you got it, right? I said multi-hop. Okay, great. So let's look at question 8. So what happened in question 8? Anyone want to take a guess here? In a multi-hop TCP/IP network, the network layer could remain the same. Is that true or false?
I think it's true. The IP address, the source and destination IP don't change on no matter what.
Okay,
So I
okay,
think-
so great. So Sia and Benita say true, but Wanjun has a very interesting point. Anyone want to look at that? Sia and Benita.
Oh,
Yes.
the time to leave.
Yeah, there's a TTL field, which is the time to live, right?
Okay,
Which is
yeah.
decremented on every hop. This is essentially to prevent routing loops, right? We saw that, for example, distance vector and sometimes even link state can get stuck in routing loops. And so this prevents a packet from hopping around the network forever.
Oh, okay, yeah.
Okay, so this one would be false because time to live changes on every hop. But you guys are right. The source and destination MAC don't change. Well, unless, well, if we have a NAT, then they change, right? But the time to live always changes. Okay, great. So are we okay with this one? Let's go back to. Okay, let's go back to the beginning. How can a TCP/IP flow increase its link utilization to the maximum allowable? Okay, so maybe let's just go over it one by one. Can nodes increase MSS? Yes or no? Is it yes or no? What do you think? But MSS is the maximum. Okay, so we're Muhammad Asif Humayun, are you answering this question? Sorry, I couldn't see when you typed it. Is it with respect to this question? Can nodes increase MSS? When you wrote no, was it for that? Okay, and oh yeah, okay, yeah. So can you explain why can't nodes change the MSS? Isn't that something nodes can do? Maybe. Yeah, but maybe a node can ignore it. You're right. It's typically set by the network, but let's say we have a, I don't know, a node that's not compliant. So yeah, I mean, typically no, you're right, but actually technically yes, right? Because it can just change it, right? Technically, yes. And we know increasing MSS will increase the throughput. But the question is, can a node increase MSS arbitrarily large? So that would be the question, right? And the point is no, they cannot increase it arbitrarily large. Technically, yes, but let's say up to a point. I would say not arbitrarily large. Okay, so what's the second? So that's not going to be our answer, right? What about decreased RTT? That sounds like a good idea, right? Because remember, our throughput was like W times MSS by RTT, right? So I can't increase this arbitrarily large. Can I decrease RTT? What do you guys think?
Sounds plausible.
Yes. Okay. What about you? By the way, Mohammed, Asif, Humayun, how do I address you? Do I address you as Mohammed or Asif or Humayun? Asif, yeah. So Asif, what do you think about this? So CN says, can decrease RTT. What do you think, Asif? Can you decrease RTT? Because if you can decrease RTT, because it's in the denominator, that will increase throughput. What do you think? Wanjun says can only decrease till bandwidth. Isn't it determined by the physical state of the network? Yeah, Asif, you're right. So Wanjun, RTT is not under your control. It's determined by the environment, by the network traffic. Yeah, as Pranti says, the network traffic, and Asif says by the physical state of the network. So it's not under a node's control. Okay, so that means I cannot change that. What about window size? Because that was the third thing, right? Can I increase my window size? For example, so the real question is, can I increase the window size arbitrarily large? Again, this is just like MSS. The answer is no. Right? So you cannot increase it arbitrarily large. Right? So that means the only other option is, this is Occam's razor. Once you've eliminated everything else, what's remaining is the only sort of sensible answer. So yes. So a node can open up multiple connections, and those multiple connections allow it to use up the available link capacity. Okay, good. Are we okay with this? Okay, let's go to 5. 5, I think, is pretty straightforward. Can you partition this network, this /23 subnet, the /23 network, into 4 subnets, each with 150 hosts? So if yes, do it. If no, explain why. So can anyone help me with this?
So you have like 9 bits left for the subnets, right?
Yeah.
So if you want 4 subnets that will require 2 bits, you're left with 7 bits. I can't remember what is 2 to the power 7, so you gotta help me.
Well, all you have to know, is it less than 150 or greater than 150, right?
Yeah,
So what's your guess?
let me Google it now.
Okay. Yeah, exactly right. So /23 subnet mean there's 9 bits left. You want 4 subnets. So you have to steal 2 bits from those 9 bits, which means 7 bits left.
Which will give you 128. So no, you don't have enough.
Yeah, in each subnet, and 2 to the 7 is 128, which is less than 150.
Do you have to minus off 2 from 1 to 8?
In this case, it doesn't matter.
Yeah.
Yeah, because even 1 to 8 is less than. But you're right. You would have to, if you want 150 hosts, the number of hosts would have to be 100. So the number of addresses would need to be at least 152. right? So the answer is no.
Wait, Prof, can I ask the previous question?
Yeah, sure.
My friend is not here, but he asked me regarding the opening multiple connections, right?
Yeah.
Wouldn't it be limited by the network's bandwidth?
So that's the whole point. We are trying to maximize the link utilization until the network bandwidth.
Oh,
That's the whole point. Yeah, we can open up connections until we get to full utilization. So you're right. Beyond that, we can't. But that's what the question is asking. How can a flow increase its link utilization to the maximum allowable?
okay,
Right?
thanks.
To the link network bandwidth. Does that make sense, Wenjun?
Yes.
Okay, cool.
Yeah.
Okay, great. Okay, so I think we're okay with this one. Question 6 says, okay, question 6 is straightforward, right? It's just this, right? There's nothing magical here. You just need to get your units correct, right? So 48 kilobytes over 30 milliseconds. You just got to get your units right, because I ask you to do this in, okay, in this case, it's megabytes per second. So you don't have to convert bytes to bits, right? So because if you look at the answer, it's in megabytes per second, but the answer was in megabits per second, you'd have to do some conversion. But if you work this out, does anyone, can anyone work this out? What do you get here? Actually, it works out very nicely because the kilo 10 to the 3 and milli 10 to the -3 kind of cancel, right? So what do you get?
Prof, can I ask something about this?
Yeah.
What's the I noticed that there's two different equations. Like one includes the product of the maximum segment size, while this one doesn't. So what's the difference? When do we use?
Okay, so it depends on what units you want. So for example, when we like if we write this, right, and W is segments, right, and RTT is seconds, then the down here, this units is what? Segments per second, right? Right?
Yeah.
If let's say in this case we wanted, like, for example, bytes per second, we'd have to, for example, convert segments to bytes. If each segment has MSS bytes, then we'd get like W times MSS over RTT. In this case, MSS is in bytes, right? Or it is segments per byte. So the units of this would be maybe bytes per second. Now, in the problem, I just gave you W in bytes. Right? So the point is the throughput, the definition is throughput. The numerator is how much data you get through. The denominator is in what time frame. And you just need to work out the units. Does that make sense? So here I want I'm giving you this in bytes per second, and this is in seconds. So when you if you just do like window size by RTT, you will get something in bytes per second, which is what I want. I want the units to be bytes per second. Does that help, Wenjun?
Yeah.
But if, for example, you wanted to compute it in segments per second, yeah, and you were given the window size in segments, then again, it would just be W over RTT. But you understand, like, where you get like this formula and this formula, it's the same formula, just depends on what you want your units to be.
I understand.
Okay, good. So what happens here? This ends up being what? Can anyone do the math for me? I think this is just 48 divided by 30, right? And I think everything just works out. Right? So this was D here. Everybody good with this one? Okay, so this was just a straightforward application of our first order approximation. We already did this one. We've done this one already. Okay, how about this one? Number 9. What is the shortest path from node A to node C in the network shown? So we want to go from node A to node C. And what is the shortest path? So anyone want to help me with this one? Can I ask someone to help? How about you, Divya? Are you with us?
Yeah, hi.
Hi, any thoughts on this? Like how do you want to look at this?
Okay. According to the, like, if you just add the values and not consider that it is negative,
Mm.
the path is ABDC.
A, B, D, C. Yeah,
because
that
it
sounds good.
comes to -3.
Okay,
Considering that you're not like you're okay with the negative edge.
okay. So you say it's A, B, D, C.
Mhm.
Okay, take a careful look at this graph. So let's say you do A, B, D, C, right?
Yeah.
Let me ask you to go back to B,
Mhm.
then D, and then C. What happens?
After ABDC.
Yeah, A, B, D, C, and then I go back to B, D, C.
Okay.
I can do that, right? Because I can follow the arrows.
Yeah, then you get more. Oh, okay.
So you considered A, B, D, C, so that's good. What was the cost of that?
-3, and
Uh-huh.
if you go
What
back
happened?
to
Yeah, A,
Yeah.
B, C, and go to B, D, C. What's the cost of that?
-4.
So you see a problem with this graph? What's the
Yeah.
problem with this graph?
It's like a cycle.
Yeah, there's a negative cycle,
Mhm.
and negative
Yeah.
cycles are not good at all, right?
Yeah.
Negative cycles make the graph meaningless, or they make the question of shortest path not a sensible question. So here would be none of the choices. Okay, so here the question of shortest path is not relevant. Okay, is not relevant. Okay, sorry, Divya, a little bit of a trick question.
Yeah. I made a mistake in this.
It's
one.
okay, don't worry about it. The whole point of
Thank
this
you.
question is to learn. Bonita, you asked about 1024. No, don't take 1 kilobyte to be 1024. Take it to be 1000 bytes. Okay. Are you okay with that, Bonita? What happened in the first half?
The lecturer didn't explain. So
Okay, so you should, okay, so this is sometimes tricky, and actually it's not really tricky. It's just it's a convention problem. Let me share my screen here. Let me plug in. For the moment, let me unshare my. Oh, maybe I can just do it here. Okay, you guys can see this, right? Yeah, okay. So key. Okay, so here, no, I want to do
EB byte, right?
EB byte, yeah. So, yeah, so this is the general convention. A kilobyte is 1000. If you want to use 1024, typically people use something called kibibyte.
I think my confusion is that for like the first half,
Yeah.
I think in the examples that we went through, we took a megabyte as 2 to the power of 20. Like when it's written in the questions.
Oh, I see.
I'm not sure what to.
Yeah,
Like-
like I said, this can be a little bit confusing. My solution is going to be as follows, maybe a little bit unsatisfying, but you're talking about the final exam, right? So in the final exam, there's going to be 4 questions, 2 questions from part 1 and 2 questions from part 2. So you know what my solution is, Benita?
For part 1 questions, I take 1024. For part 2, I take it as 1000.
Yeah. Okay, but this is a, if you will, I mean, it's just a hack. I like to think longer term, right? I want you to learn. And this is the convention that everyone has agreed upon. Okay, so longer term, this is what I would do. Does that make sense?
Yeah.
Okay, I mean, this kind of industry has decided based on this. You know, this 1024 and 2 to the 20 typically applies to storage. Actually, it's the storage people that mess things up. They yeah, like when you buy like a hard disk or something, you know, they use this convention. But I think it was from a metric system, you know, the standard units, kilo means 10 to the 3. It does not mean, guys, give me a second. My boss is calling. Hang on. Okay, I'm back. Sorry. Yeah. You probably can guess who my boss is. So, okay, are you guys okay with the solution? Is everybody clear? I think that if you are, let's say, unsure, just state your assumption. Okay? Benita, all right? You can just state your assumption. Because the whole point of an exam or test is to test whether you understand something. So if you make an assumption and what you did is right according to your assumption, it won't be marked wrong. Okay, good. Anyone else? You guys are okay with this? But I thought I just shared this idea here of kilobyte versus kibibyte. Okay, so this is sort of the new, not new, but this is the industry standard. Yeah, as I said, it's the memory, the solid state memory capacity, the storage industry that really changed to 2 to the 10. Okay, good. We can go back to what to call a note. Okay. Okay.
Prof, for this question, right, the one with the negative edges.
The negative cycle, yeah.
Yes, yeah. I mean, okay, I understand that, you know, there's like cycles, so the cost would change. But I mean, looking at it from like an absolute perspective, suppose you're given such choices like, you know, A, B, C or A, B, B, C, then do we still choose none of the choices? Because from the given options, A, B, D, C is the shortest, if you understand, like, you know, what I mean.
Yeah, I understand what you're saying, correct. Yeah. I wouldn't. I mean, this is a sort of a philosophical question that you're asking. Who's asking? Is Pranati?
Yes, sir. Yeah.
Yeah, I think it's like a philosophical question. Yeah, I mean, in this, I wouldn't answer the question. The question is not
Okay.
answerable.
Okay.
I mean, it's true, right? There is no shortest path from A to C, and you can't draw the shortest path spanning tree.
Right. Okay.
Yeah, I mean, now a different question. If you were asked, if I ran Dijkstra on this, what would the output be? That's a fair question, because Dijkstra, remember, Dijkstra terminates.
Yeah.
It can take input and it will terminate. Now, its output is not, in this case, not the shortest path spanning tree, but you could be, I mean, one could run Dijkstra on this and get an answer. It's not to say Dijkstra won't return an answer, because Dijkstra is a deterministic algorithm. But the fact is, I'm not asking you to run Dijkstra. I'm asking you a conceptual question. What is the shortest path? And it turns out that it doesn't make sense to ask it. Because
right.
the cycle. Yeah, I apologize,
Okay.
but yeah, I mean, maybe this, yeah, please forgive me for the trick question. but I think this is a question from which we can learn a lot. Hopefully you learn like long term. And you know, the philosophical question is, I think, and you're going to encounter this a lot when you enter the work world, you know, when you enter industry and so on. I think each of us needs to maintain our principles and integrity, no matter what the environment around us wants us to do. And right, I mean, if you know something is not the right thing to do, even if everyone's telling you to do it, does that mean you do it? Even if your work says it's okay, but you think it's wrong, do you do it? No, right? I mean, that's integrity. And in some sense, this falls under that. That's why I meant it's a philosophical question. Yeah, you don't need to answer a question just because you're being forced to answer a question. I think I wouldn't answer the question here.
But Prof, if we put A, B, D, C, will we be penalized? Because
It'll be
technically
wrong.
it's like,
No, it's wrong. Yeah, I mean, here you will not get credit for
but
choice.
they didn't ask about the distance though. They only asked the shortest path.
I mean, it says, what is the shortest path from A to C? I mean, A, B, D, C is not the shortest path, right? Now, you could say, like maybe your point is, given these three choices, which one has the least cost, right? Then you could answer that, right? Amongst A, B, C, A, B, D, C has the least cost. Like amongst choices A, B, C. Does that make sense?
So, Prof, you're basically saying, like, you know, in ABDC, you're at C, but then you could, I don't know, like, add another BDC and then you'd be at C again, but the cost is lower.
Yeah.
So in that sense, it's not the shortest path.
Yeah, it's not. Yeah, exactly. In that sense, it's not the shortest path from A to C.
But then wouldn't you just consider the first time you reach C and not like cycling around C over and over?
Maybe if you had a policy like that, yeah.
Okay.
But I mean, all of you are on the right track in terms of your thinking. So please, I don't want to change your thinking. Okay, but I hope we understand the principle here. Okay, great. Can we move on? Don't worry, we were very generous, okay? So I don't want you to be so worked up about this. Okay, how about this one? Question 10. We have two routers connected by a 20 megabit per second link. 5 TCP flows and 1 UDP flow traverse this link. Assume that this link is the bottleneck for all these flows. All have the same RTT, the same max data rate. And I want to say, what's the average throughput of a TCP flow? So this one, the idea is that the UDP flow is not nice, right? UDP does not do congestion control. So the UDP flow will consume all that it can. And how much will it consume? Well, I told you each flow has a max data rate of 5 Mbps. So we'll consume 5 Mbps, right? Then this will leave 15 Mbps for the 5 TCP flows. And TCP is nice. TCP is going to do essentially max min fair, right? And in this case, max min fair will give you it will just divide this equally. Okay, so this one will be A.
Hey, Prof, for
Yeah.
this question, right? I believe you told us to make like a change to the phrasing. So you told us to add what is the average throughput of all the TCP flows, I think. Yeah.
No, I think the clarification was each of the TCP flows.
Oh, okay.
Yeah. Yeah, I remember there was a clarification in class, but it was each.
I see.
Yeah.
Well,
sorry.
at least I got the thinking right. That's more
Yeah,
important.
but don't worry. I you know, as I said, I've instructed the TAs to to be generous.
All right, thank you.
Okay, let's look at 11. In this network here, again, this is, so I think there was, at least I remember during the quiz itself, some people didn't maybe notice the arrows. So please be careful when you look at a graph. If you see arrows, it's a directed graph and you can only go in the direction of the arrows. Okay, so like both for the previous question with the negative cycle, it was a directed graph, and also question 11 here. In the network shown, Y and Z are integers, and Dijkstra's algorithm at node A may not find shortest path because there may be negative edges. So is this true or false? So we're looking at here, node A, and there's some negative edges, and I'm saying Dijkstra's algorithm, while it will terminate, it may not work correctly. Is this true or false? What do you guys think?
I think it's false if the negative edges are on the originating nodes. That's sure it was done properly.
Yeah, exactly. So here, A can see the possibly negative edges. On the first iteration, on the first step. So being greedy does not hurt you, right? The whole problem with negative edges is that being greedy, you know, at some point, being greedy can hurt you because in the future there can be a negative edge. But here that cannot happen because Y, Z are incident on A. Okay. So the answer here would be false. Okay, let's go to this last question. Suppose that subnets are defined by, so I'm giving you a notation here, IP and subnet mask. And then I give you two subnets. Right, notice that this is different. Normally we would do something like, you know, 1.2.3.4/16. But here I'm giving you a slightly different way. Remember, there were a few different ways of describing a subnet. I can specify a dotted decimal notation or version of the subnet mask, and that's what I'm doing here. Okay, so I give you two subnets, and I want to aggregate them, and I'm asking which one does it correctly. So we are trying to look at 12.20.164.0, and the subnet mask is 255.255.252.0. So, I mean, one thing you could do, you could just turn it back into this notation, right? So let's do that. Then how would you turn this subnet into the slash notation?
So 252 is like minus, it's like -3, right, from 255. So that's like the first and second bit. So you instead of 6 bits, they are all ones. So that's 22 bits of ones in the mask.
That's right, exactly. So this is 20. So this turns into this, right? Does everybody see that? If not, ask and I can help you. And then the other one is what? 112.20.166.0 with 255.255.254.0. Yeah, this one is just one more bit, right? So this changes to 12.20.166.0 / what? 23. Yeah, is this what you also got? Who was talking before just now? CN?
Yeah,
Yeah, so this is, did I do this right?
I think so. Yeah.
So now we can easily aggregate these, right? We just need to look for where they overlap. So this is 22 bits in the subnet. This is 23 bits. When you write it out, you will find it's the first what? So this is 12.20. What is it? 101. I hope I did this right. 001 00.0. That's the first one. The other one is 101 001 10.0. Right. So the common one is these 6 bits, right? So it's going to be 16 plus 6. So we'll get 12.20.164.0/22. This is the aggregation of those two. Does that make sense? Okay, so I think that takes us through all of the quiz questions. Can I check? Are there any other questions that anybody has about anything else?
Prof, I have a question.
Yeah, please, Wanjun.
It's actually related to the grades. Actually, I'm quite curious, like how I don't know how to make of it, because I see like the high is 42, but then the upper bound of the score is out 40. So I'm wondering why.
Yeah, let me check on that. I'll get that fixed.
Yeah. Then can I go through the past year paper question?
You can ask me a question, yeah.
Okay.
You want to share your screen?
I'm using my Zoom on my phone now.
Okay.
But give me some time, I transfer. Oh, also can.
Let me I can try to bring it up. Okay, hang on.
Okay,
Let me stop this sharing here.
It's I think it's regarding the recent paper.
The one I released?
Yeah, 2 days ago.
Okay, let me bring it up. Give me a moment. This one, right? Hang on. Zoom, share. This one, yes, right?
Yes. Question 4B, they ask design an efficient protocol. So I'm not very sure what is required of 4A.
Okay, yeah. This one, right?
Yeah.
Okay. 4A or 4B?
Maybe the whole of
B, right? This is the
4B, yeah.
Okay, so you're designing a multi-hop network that can tolerate 5% packet loss. Okay. Yeah, so like
what I would say TCP, because you need to maintain at least a minimum 95% of the packet. So I would say TCP might help these.
Yeah. So what you're saying is that TCP will meet the requirements, right?
Yeah.
Okay, first of all, will UDP meet the requirements? What do you think? Will UDP meet the requirements?
When I was doing this question for the first time, I thought it was UDP, because I thought TCP like guarantees no packet loss, since there's like all the fast retransmission and the timeout. My friend told me it's TCP, and I thought about it, and I was wondering which is correct, because technically UDP, like multimedia streaming, you can accept like data loss, the packet loss.
Just give me a second. Hang on.
Okay.
Sorry, I'm just trying to sort something out. Give me a moment, if you don't mind. 20. Okay, so Yeah, okay, so sorry, I was there was something buggy here. So the first part, can UDP be used?
I'm not very sure because if I remember correctly, like in multimedia network they use UDP, then because they can accept packet loss. Then I thought
Right.
TCP also. TCP can.
But here you're given a requirement to tolerate
Oh,
only 5% packet loss. Can UDP do that?
no.
Right. So for part one, which one would you
TCP.
recommend? You cannot use UDP, right?
Oh,
Does that make
yeah.
sense? Yeah.
Hmm.
But TCP is overkill because what will TCP do?
Timeout and fast retransmission.
Yeah, no, but TCP will give you 100% packet delivery, right?
Oh yeah.
So it's a bit overkill. So part two says design a protocol that meets the stated requirements using the least amount of resources. If you use TCP, you're going to use more resources because you're going to get the 100%. So can you think of how you could? Yeah, I mean, this requires you to think a little bit out of the box.
Is it similar to the test paper where you mix up the TCP and UDP together?
Mix them together. I'm not sure what you mean by the test paper where we mix it together.
The previous question, you covered during just now the consult. There's a bandwidth of 20 Mbps and
Oh no.
TCP and
No. I mean, in that there were different flows those were different flows, right? Different UDP and TCP flows. Here, this says I have one flow, and I want to tolerate 5% packet loss. How would you do it? So the point is, transport layer cannot handle it. Right? Transport layer either gives you 100% guarantee or no guarantee.
We can do it at the application layer.
Sorry, was someone else speaking?
Yeah.
Yeah, who's that?
We can use UDP, but we can do the retransmission and checks at the application layer.
Yeah, correct. But why would you? Yeah. So I think CN, like that's a nice way of looking at it. So your idea, if I understand correctly, use UDP at the transport layer with no guarantees, and do all of the guaranteeing at the application layer. Yeah, I think that's a solution. Anyone have any other solution?
Hi, Prof.
Yeah, hi, Benita. Yeah.
Can I just drop 5% of the packages at the source?
Yeah, exactly. You can just do that. You can use TCP at the transport layer, and then just drop 5% of the packages at the source. So both those solutions work. Yeah, I mean both those solutions work. I mean, the whole point here is to think out of the box, right? Yeah. Wenjun, does that make sense? So
why will you drop 5%?
Because
intentionally.
Because the protocol says the application can tolerate 5% packet loss. So you're right. Normally you wouldn't do that, but here you're given that the network can tolerate 5% packet loss. So yeah, you could do it as what CN said. You use UDP and you get the 5% or the 95% at the application, or you could just use TCP and get the 5% packet loss at the application layer. But again, there are probably a lot of solutions here. There's no one right answer for this. Okay, Wenjun, I'm sensing it makes you a little bit uncomfortable when there's no one right answer.
As in regarding the intentionally dropping 5%, it's a bit weird. Even though it
sounds weird, yeah. I mean, it sounds weird. You're right, yeah. But yeah, I mean, sometimes like weird things can happen. So for example, if you look at like airlines, right? Airlines oversell seats, right? You would ask the question, you only have 100 seats. Why would you sell 120? Makes no sense. Well, they have their reasons. So yeah, you're right. I mean, it sounds counterintuitive, but yeah, I mean, if the system can tolerate it, then you would do it, right? So in this instance, the airline oversells seats because customers are willing to give up their seat for some money. Okay, cool.
Mm.
Okay, great. Anyone else have any questions?
Hi, Prof.
Yeah, hi, Benita.
Go through 3A part 5. I'm not sure if my approach is correct.
All right, 3A.
Part 5.
Yeah, let me look at this. I haven't looked at this in a while. Let's see. We have this IP address, starting and ending, right? So what we want to do is look. Yeah, I mean, like we can just start from the top, right? First of all, how many addresses are here? Can you figure that out? Did you get that part, Benita?
Yeah.
What is it?
128.
Yeah, it's 120. How did you do that?
255 minus 128 plus 1.
Yeah. Okay, good. Then the second part is also easy. Like once you know that, you know how many bits are in the host part, right?
Yeah.
So you can figure out. So what's the how would you write this in the slash notation?
114.44.23.128/25.
Yeah, exactly, right? Because you know that the 7 bits in the host part, so 25 bits in the subnet part. How many bits? Okay, this is pretty easy. It's 25 and 7. Then I want you to write it in dotted decimal notation, and this is pretty straightforward, right? The subnet mask, you would just put 25 ones, right? And then the rest 0.
Yay.
And broadcast address, you would just put all 0. You would have the 25 bits in the subnet, and then the 7 bits all ones.
Yeah.
Okay. And then it's part 5. Can you divide the subnet into 3 subnets, each with 35 hosts? So, like, can I ask how you're approaching that?
I said no,
Okay, why?
because firstly, the division of subnets have to be in orders of 2. So the best division I can have is 32, 32, and 64. Which means that 2 of them won't get at least 35 hosts.
Yeah. So I think that makes sense.
Oh.
Yeah. What was the confusing part?
Because I've never had to divide a subnet into 3, so I was wondering if there's any other way other than dividing into 4 and then assigning 1, 1, and then 2 to 1 subnet.
Actually, you did it in a very efficient way. The kind of the standard, let's say, if you don't think too deeply way, is you just you take 2 bits from the 7 host bits, right? And you create 4 subnets, and that leaves 5 bits for the subnet part. That gives you only 32 bits. 32 hosts, which is less than 35. But you did it in a really clever way, right? What you did was you said, for those 2 bits, I'm going to use what? 1 bit to determine, like let's say the 3 subnets are A, B, and C. 1 bit will determine A or B and C. The second bit will determine B or C. Right? And in that way, you get A can have 64 and B and C can have 32. Right? That was your solution, right?
Yeah.
Yeah. So that's actually a little bit clever solution. I mean, it still doesn't work. It still doesn't satisfy.
Yeah.
But like, if I were to ask you, break this into 3 subnets such that, each subnet has the maximum number of hosts, then your solution would be the clever solution.
Okay.
You get what I'm saying, right?
Yeah.
Okay, so to answer this question, the answer is no. But I realize there's something very interesting in your solution. Your solution is a little bit clever, so nice job. But it doesn't affect this question, but it shows that there are different ways of breaking up subnets, some better than others.
Okay. Thanks, Prof.
Yeah, does that make
Yeah.
sense? Yeah, okay. Okay, anyone else? I mean, okay, we can just, if people have questions, like this is, B is pretty straightforward, I think, right? Is it?
4A part 3.
Oh, 4A part 3. Let's do that.
Yeah, whether we can drop timeout and just use triple duplicate acknowledgement.
Okay, let me read the question. maybe we just, okay, 4A, we just do 4A. TCP uses 2 signals, timeout, and triple duplicate acts. Both events trigger the retransmission of a packet. Okay. So first of all, how about the first part? Who asked me that question?
Me.
Wanjun. Okay. So maybe you just take me to the first part. In each case, which packet is retransmitted?
For I think triple duplicate acknowledgement, I would think is the packet with the sequence number in the acknowledgement.
Okay.
And the timeout, it will be the packet that was last transmitted.
Yeah. So well, no, it's a packet, not that was last transmitted. It's a packet. Remember, TCP uses sliding window, right?
Mm.
And for each packet, there's a timer. It's the timer that expired, right?
Yeah.
Yeah. So in both cases, they will just retransmit the packet that was believed to be lost. Because in each case, you know, the sender has a belief about which packet was lost. So that's this number 1 here. Okay. Wanjun, does that make sense? You sound a bit hesitant.
Yeah, it makes sense.
Okay. Give one reason why TCP uses duplicate acts to trigger retransmission instead of simply waiting for timeout. So how
This one I saw in the notes, they gave like an example, like they gave the numerical example. I'm not sure whether they can just write like inefficient utilization of bandwidth, or I must like give a numerical example to
no, you don't have to
demonstrate my
give,
point.
no, you don't have to give a numerical example, but you have to give something that logically makes sense. Just so maybe this is addressed not to you, Wanjun, but to the whole class. Don't just give an answer because it sounds right. It has to logically make sense. So why would you use triple duplicate acts instead of timeout? Why would that be more efficient usage of bandwidth? That doesn't jive completely with me. Like it may be the case, but it seems like maybe it's not direct, right? What's a direct reason? Evan, do you know? Evan, are you here? Maybe you can't hear me. But okay, Wanjun. So any other thoughts or anyone else? Why would I use triple duplicate acts instead of timeout?
To waste that time.
Yeah, because it's faster sometimes. Wanjun, right?
Yes.
Sometimes you, especially when you have bursts of data in sliding window, when your window size is large and you have a high burst out, you will get triple duplicate acts before the timeout. And that's the reason why it's a better utilization of bandwidth. So it's not I don't think it's instructive to say better usage of bandwidth. I think it's more instructive to say it's faster.
Oh, okay.
Does that make sense?
Yeah.
Okay. So when you guys are answering questions, make sure you tie that your answer makes logical sense. Always ask why. Right? Like if you want to say bandwidth, better usage of bandwidth, why? Oh, it's better usage of bandwidth because I can transmit with less delay. I can retransmit with less delay. It's faster. Okay, Wanjun, is 2 okay?
Yeah.
3 is it advisable to remove timeout and use triple duplicate acts as the only way to trigger retransmissions? What do you think? If triple duplicate acts are faster, why not just use them instead of timeout?
X themselves can be lost if the network is congested.
Say it again.
The acknowledgements themselves can be lost if the network is really congested.
Yeah, so that's a good observation, Chien. So anyone have any other reasons? What did I tell you before about why are triple duplicate acts faster? What did I say? When are they useful?
There are subsequent packets that will arrive.
Yeah, that means you have subsequent packets you've transmitted. So what does that mean? What's your window size, Benita?
Sorry?
the hint is it has to do with the window size, right? The reason you have triple duplicate acts is you have packets that need to be acknowledged, right?
Mm-hmm.
Yeah, so that means your window size is big.
Yeah.
Does everybody see that for you to get a triple duplicate ACK, you need to have other packets getting through? That means your sliding window size is large. Large enough to get triple duplicate ACKs, right? I mean, large enough to send packets to have ACKs with the triple duplicate ACK inside it. So the answer is you cannot do away with timeout. Why? Have I lost you, Benita? Or
You might not get triple duplicate act.
Yeah, you might not get it because your window size maybe, suppose your window size is small. Then there may not be enough packets for triple duplicate acts. In which case, if you remove timeout, you'll never time out. And you'll never get a triple duplicate act. And you'll be stuck for a very long time. Does that make sense, Wanjun?
Yeah, I understand.
Yeah, so if you have large window sizes, then there's opportunity for packets to get through and opportunity for triple duplicate acts. If you have short window sizes, there may not be enough packets for triple duplicate acts. Make sense?
I understand.
But Benita, make sense?
Yeah.
Okay, good. Anyone else? Okay, so
can I ask about the phrasing for 4C part 2?
yeah.
Because, okay, in the question, they said that assume that each flow has an MSS value of 1460 bytes and a slow start threshold of 8. Then for part 2, they said after some time in the future, say time t equals to 100 seconds, do we assume that the slow start threshold is still 8? Or do I assume that slow start threshold is very large such that I won't hit it?
Let me see. So what does it say? Let me read this thing at 2. Suppose that RTT, okay, also each flow. Okay, what about part 1 first? Let's just do part 1. How would you do part 1?
Flow X. Cost throughput is inversely proportional to RTT.
Yeah, because it has lower RTT, right?
Yeah.
Okay, and how about part 2? At some time in the future, both flows experience a timeout. They set their congestion window size to 1. Your question was, is the slow start threshold value 8? Yeah, no, in 2, you don't assume that.
Okay, if I don't assume slow start threshold equals to 8.
Wait. Let me check. No, sorry. No. It's written outside the problem, right? So yeah. Sorry. Like I said, I haven't looked at this in a while. Yes. So it's written outside the problem, so you would apply it. Yes.
Okay.
Sorry. Yeah. So in this case, let's look at flow X. So flow X is going to send. So they're both going to set their congestion window to 1, right?
Mm-hmm.
So flow X is going to send 1, 2, 4, 8. And that's the slow start threshold. And then it's going to go into AIMD.
Yeah.
Then it goes 9, 10, 11, 12. Now you have to figure this out. At t equals 100 seconds, 100. So if flow A is going to send what? Did you do this?
I did, but that's why I got big, because for this question, I assume that the slow start threshold is still 8 even after that timeout.
Yeah, assume it. So then it goes 1, 2, 4, 8.
In 1 second, I only have 10 round trip times for flow X. So I just did 1 + 2 + 4 + 8 + 9 + 10 + 11 + 12 all the way to 15.
Yeah. So how many segments?
I don't know. I punched it into a calculator.
Okay, I think it should be 99 segments.
Yeah.
So that gives you the flow, right? That gives you the throughput.
So for that, I just multiply it by the minimum segment size, and then that will be my average throughput.
Yeah.
Okay.
Actually, it's maximum segment size.
Oh my God. Yeah.
Like,
Thank you.
Yeah. So it would just be 99 times 1460 bytes per second. Because it's in 1 second, right? That happening in 1 second, right?
Yeah.
Then how about for flow B?
1 + 2 + 4 + 8 + 9 + 10.
Right. Because that's
It's only 5 RTTs.
right. So that's 35. Sorry, 34 segments.
Mm-hmm.
Right? You 1, 2, 4, 6. Yeah, it's 34, right?
Mm-hmm.
And then that one is just 34 times 1460. Yeah.
Okay.
That makes sense?
Yeah.
Okay.
Because I think when I did the question the first time, I assumed that, like, even though the original slow sharp was 8, since it ran all the way to t equals to 100, there was not any collision. So I assumed that my slow start threshold was really large.
Right.
And I got a throughput that was very, very large.
No, these things take a little bit of thinking. So you're right. Even for me, when I read it, I had to do a double take, right? So it's not just you guys. You have to read questions carefully. Yeah. But yeah, I think so I hope everyone else was following. All we did here was for each of the two flows, flow X and flow Y, right? The RTT is 100 milliseconds. So there's actually 10 RTTs. Right. So because this says calculate the throughput in the next 1 second, since this is 100 milliseconds, there's 10 RTTs. So you just have to count how many packets or segments are sent in 10 RTTs. Here is 200 millisecond RTT. So in 1 second, you have 5 RTTs. So for flow Y, you just have to count how many were sent. Okay. So if I don't know if you understood the counting that Benita and I were doing. If you didn't get it, just ask.
Do you mind illustrating for one of the flows?
Yeah. So why don't you do it with me? So look at flow.
Sure.
X here. So look at flow X. It has an RTT of 100 milliseconds.
10 RTTs in 100 seconds. Yeah.
Yeah. So you got to figure out. Okay. And in the beginning, it's going to do slow start, right? So it'll do 1, 2, 4, 8.
Yeah.
That's 4 RTTs, right?
Yep.
And then after that, you go into AIMD. So in the 5th RTT, how many segments will it send?
9.
Right. So now you just count 8, 9, 10, 11, 12, 13, 14. Do we end at 14 or 15? 1, 2, 3, 4, 5.
15.
You end at 15. Yeah. So that's after 10 RTT, you've sent 15. You'll send a round of 15 segments.
Is it on the 10 RTT? Is it 14? 1, 2, 4, 8, 9, 10, 11.
No, but after that 10th RTT, you
Oh
will
yeah.
segment.
After that, yeah.
Yeah, you will. So I think we talked about this in class. You count the segment you send. So you don't count the weighting of that last RTT, but yes, you will at the 10th RTT, after 10 RTTs, you have sent that 11th chunk of packets, which is 15. Does that make sense? Yeah.
Yep.
And you just add up 1, 2, 4, 8, 9, 10, 11, 12, 13, 14, 15. That adds up to 99.
Yep.
So that's 99 times 1460 bytes in 1 second.
Wait, what?
Because up here, right, each segment is 1460 bytes.
You count your throughput. You count the number of packets is up to the 100th second, right?
Yeah, that's 10 RTTs.
Yeah. Okay.
Not to 100 seconds. It's not this. It's to 1 second. 1 second, right?
So the 101st second, no?
Yeah, correct.
Oh, okay.
So it will be, let me see. I think you're the people a bit confused here.
Yeah, I am sorry.
No, so flow, what is it? Flow X, right? It starts off at 1, 2, 4, 8. Okay. Then 9, 10, 11, 12, 13, 14. Now you might ask why stop here. So this is on the, when you start, you send one packet. After one RTT, you send 2 packets. That's the convention, right? So after one RTT, you will have sent 3 packets. Okay, so this is, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 99 segments. But we have 1460 bytes per segment. Right? Why? It's given here, right? What's the throughput? So this is 99 segments in 1 second. 1460 bytes per segment. So your throughput is 1460 is 99 times 1460 bytes per second. So it depends on what units I want you to put this in. In bytes per second, yeah.
Just to clarify, so after one RTT, you will send 2 packets, right?
Yeah.
Oh, okay.
No, 2. You will send 3.
Yes, 3. Got it. Yeah.
Okay. Does that make sense? And then you can do the same thing for flow Y, but because the RTT is 200 milliseconds, you only get 5 RTTs. You get 5 RTTs in 1 second.
Yeah, I think I read the question wrongly, but I got it. Thank you.
It's okay? Yeah, okay. Benita, this is consistent with what you think now?
Yeah, my query was regarding the slow start threshold.
Yeah, but you got that part, right? Yeah, I mean,
Yeah.
It applies. Yeah, it applies because it's outside. I also missed that to start with, but yeah. Otherwise, you're right. You would just essentially get 2 to the 11
Summation of exponential.
Yeah. Yeah. Actually, it turns out there's a closed form expression for that.
Yeah. But the throughput was just very, very large.
Yeah, it will be large. Correct. Okay, let me not mess up my. Okay, is that okay? So everyone good with that one? I guess we can try to just finish. What's 4D? 4D just says what? The evolution, you want to...
My friend has a question.
Okay, let's just finish 4D here.
Yeah, okay.
So what will this be? Okay, here's A, B, C, D, E. What are they? What's A?
I think it's exponential. Slow start.
Yeah, this is like, in primary school, you had to do close or something where you given a bunch of words and you got to fill them in like my kids do it. Do you guys remember this in primary school? That's what this is. You got to choose it from this batch here. So what's A?
Slow start.
What's B?
Timeout.
Okay, C?
Slow start again. Edit. Slow start.
What's D?
Additive increase.
And then E?
The slow start threshold.
Yeah. Okay. Well, and you, somebody said, was it you, Wanjun? You said you or your friend had a question. Are you like texting your friend? Is he texting you?
Yeah, because my friend is like, we had an exam before this, so I think he's still rushing home.
No problem.
Yeah.
What's the question? Yeah, which one?
It's regarding the test. Actually, there's 2 questions. First question is, just now Benita explained why we cannot split the subnet into 3M. Are you able to explain that part again?
Can you try? So the answer to this is no. But can you try?
Because I didn't think that deep. I just check the number of hosts that is allowed. Then I see 3 times 35, and since it's less than that, I say it can be divided.
I see. No.
Yeah.
Because so in this problem there were what, 7 bits in the host, right?
Yeah.
of the original subnet, right?
Yeah.
So that means now let's take the simplest case. If you need 3 subnets, then one solution is need 2 bits, right? For like to differentiate 3 subnets, right? Because 1 bit only lets you differentiate 2 subnets. So
Yeah.
you need at least 2 bits, right? Yes or no, Wanjun? Are you with me?
Yes.
So that means you only have 5 bits left for the host in each subnet, which means that you have 2 to the 5 or 32 IP addresses. And
Oh.
32 is less than 35. Yeah,
Oh. Understand.
okay.
Hmm.
Yeah, so there's just not enough space. Is that
Understand.
clear? Yeah, okay, great.
Yeah. Then regarding the quiz 2, he asked why the, go down to the chat. He asked why we cannot increase the maximum segment size and the window size to an arbitrarily large value.
Yeah.
I'm thinking regarding the maximum segment size, is it because it's capped at like 1,500 bytes or something?
Yeah, I mean,
There's a limit.
you can increase it, but not arbitrarily large, because there are other mechanisms in the network as well. So for example, the network layer has a packet size as well, right? There's a maximum transmission unit.
Oh.
And that one is definitely out of your control, because that's implemented at a router. It's not implemented at the host.
Okay.
So you cannot increase the MSS arbitrarily large.
But what if the route? Oh, no, never mind.
Does that make sense?
Yes.
Yeah. Okay.
Then the other one is the, let me see. I think it's the window size. Window size, is it because they will time out? Or it is?
It's because remember the sliding window size is the minimum of the
flow
congestion
control
window and the flow window, right? So yeah, so the flow control window will control that as well. So you can't make it arbitrarily large.
I understand.
You can increase it, right? That's how congestion control works. It increases, but it always takes the minimum of the current congestion window and the flow window.
Get it.
Yeah.
Hey Prof, I just want to say thank you this sem for asking us all the why questions. It helped a lot with my learning. Yeah.
I'm glad that's the whole point. Yeah. And it's actually it's how I think too. So I hope to have affected you guys in the way you think as well. So you can bring this to your other classes and to your work.
Sure.
Yeah.
So I guess I'll go and study now. I'll be going now.
Cool.
Thank you for your good teaching.
Yep. Thanks everyone. And
I have two admin questions.
Yeah, go ahead, Wanjun.
Where is the exam? Where is the exam?
The exam. Let me check. Is it on Canvas? Let me see. Okay. Yeah, I guess it's new for all of us, right? Let me see if I can find this. What I'll do is
question is
engineering auditorium.
Oh,
yeah, it's an EA, right? Yeah. Benita, where did you see it? Is it in Canvas?
In EduRec. Under
Okay.
exam schedule.
Okay. So it's confirmed it's an EA, right?
if I didn't remember it wrongly.
Okay, I'm also gonna double check and I'll send out a notice to everyone. But it's on Saturday, right? Saturday at
Yeah, 1 p.m.
1 p.m. Yeah, should be EA. But I'm gonna just double check. It's funny, I couldn't find it in Canvas, but like I know for me there's an exam timetable I can check. Let me see, exam timetable in US. Okay, here I see it. Oh no, what is this? View exam timetable. Oh, this is dumb. It tells me to go look at EduRec. Okay, here we go. Timetable, semester 2. There we go. By module. EE4204. Oh, this thing, this exam timetable I have doesn't even have the venue. Okay, so Benita, I will trust you, but I will double check with the department and let you all know. But I do recall, like both my exams this semester are in EA. So I will double check and let you all know. Okay, anything else?
Prof, what if we have any doubts in the exam? Can we ask questions like, if your portion uses acronyms and we forgot what it is, or
Yeah,
if we have to clarify some doubts?
Yeah, you can just ask. Yeah, it's fine.
Oh,
Yeah, it's fine. Any questions you have during the exam, just raise your hand. I'll come by.
oh, okay.
Yeah. Okay, great. Anyone else have any other questions or admin or otherwise? If not, I wish you all the best on this exam and any other exam that you have left. Okay. Important thing, get some sleep. I would say that's probably important. Oh, Andy, is that you who just posted something? Yeah, I think Andy just posted something, probably from EduRec. It says Eng Auto. Oh, keep in mind this open book thing is wrong. You all figured that out, right? You saw the email from Prof. Gurusamy? Okay, the exam is not open book. It's you can have your help sheet. Okay, keep that in mind. Thanks, Andy. Okay, if there are no more questions, can we close the meeting?
Yeah.
Mohammed Asif Humayun asks, can the cheat sheet be printed? Yeah, Asif, you can print it. Can I would like you to like write it out and then print it. Is that okay, Asif? Yeah, it's fine. And then Shanghai asked to email if you encounter any other questions. Yeah, of course, Shanghai, no problem. Peng Fei says, are we allowed to use scratch paper? Let me think. I don't think you'll be handed out any scratch paper. If you really need something, you just ask during the exam. We'll tear up some of the booklets and give you some scratch paper. If I remember correctly, so you'll have to write in the exam itself. Okay. Like there'll be space in the paper to write down your questions, and there should be ample space. So you can use the space there as well. And there's some extra space for scratch paper. But if you need scratch paper, you can just ask. I recommend you, you can bring it, but I don't think you'll be allowed to use it because it's not just me there. There'll be other people there. If you need something, you just ask and we'll tear up some booklets. Okay, Peng Fei? Yeah. Okay, if any more questions? if there are no more questions, let's round up this meeting. Thanks everyone again,
Okay.
and again, all the best to you in the rest of your exams.
Thanks, Prof.
Take care, everyone. Bye-bye.
Bye.